Welcome students. Today we'll talk about a problem from NEET 2025. This was the first problem of the set and troubled a lot of aspirants. Why this problem is an issue? Many of the experts are saying it is out of syllabus for NEET. Some of them are saying we need to now prepare for JEE advanced level to solve NEET questions. I kind of disagree. The reason is this problem can be solved just by using concepts. We do not need to know too many formulas, which is out of syllabus and all those things. So let's look into the problem first and I'll explain you why. The problem says that we have a reservoir and the liquid filled in the reservoir is actually forming a curvature at the wall. We know why it is happening. That is because of surface tension. So the surface tension is trying to pull it upward. And we have been given x equal to 0, x equal to L, theta naught is much less than 1, that means theta is very small. Next is we have been given y is a function of x. Again we have been given that theta is so small that at any point of time in x, theta x is equal to sine theta x equal to tan theta x equal to dy by dt. Now look at the 3D representation of the same problem. Think of it as the side profile that we are looking for the reservoir. That means depth is inside, is going positive and negative z-axis. So I've just shown you kind of a cross section. So this is going like this as well as going towards negative z-axis. And the curvature is formed. We can see that the curve is having more steepness towards the wall than compared to when it comes down towards x equal to 0. And probably it's a straight line going forward in the negative x-axis. Now what happens that because of surface tension, this curve is formed. And this curve is formed along the complete z plus and minus z axis. So we understood the problem. We have been given 4 options in the problem. If you just look at the options, 2 of them you can simply discard by using dimensional analysis. The problem happens because 2 of the options have the same dimension. So now what is the concept? Concept about surface tension. If you know about capillarity, what happens in capillarity? A liquid is pulled upwards, right? So this is all liquid. And a surface tension force is exerted round the surface of the capillary wall. And what we do is we calculate this Fs and compare it with what? The weight of the liquid that it's actually pulling up. So this becomes equal to m into g, where this m is nothing but the volume of the hemispherical part as well as the height and rho, the density of the liquid. So what is the concept of surface tension? The water will be distorted, displaced, form a curve, stressed out because of surface tension. And if we can calculate the force due to surface tension and we can equate with the amount of liquid that is getting actually in the curvature. Okay, so what is the amount of liquid? From this image, the amount of liquid is this. So if we can calculate the volume of this and the surface tension, we can equate it, right, with the force. Very simple. Where is the problem? The problem is because this is a curve, we do not know the equation of the. So what to do? Always in those cases, calculus has taught us to take a small differential amount. How to do it? Let's see. So what I'll do is I'll simply draw this curve. So this is x equal to L and this is x equal to 0. This is my y-axis. Okay. So I need to find the volume of this. So volume with respect to, I can only see an area. Where is the volume? Volume will come from the depth. If you consider the depth to be d, okay, or 2d or x or y or z, whatever you want. So we can simply find the area of this curve and multiply it with the depth. So we'll get the volume of the liquid that is getting actually stressed, forming a curvature. Now, to figure that out, it might not be that easy because it's a curve. So what we'll do is we'll take a small portion. So this is x. We take a small portion dx at x, and this height will be what? This height is y, because y is a function of x. And because this is very small, the area is what? Area is equal to y into dx. We got it? Okay, fine. Now the problem happens, how do we calculate? So we can determine the volume, so we can determine the mass, and so we can determine the weight. What about force due to surface tension? So the force that is actually getting exerted through and through this z axis is equal to the depth multiplied by the surface tension, right? So if I say Fs is the force is equal to surface tension into depth, but it is not acting in a particular direction. So for that, we'll say this is acting at Fs, and the angle it forms, because at x, if we say, and this is Fs in this direction, and what is this angle with horizontal? This is equal to theta, and there will be slight addition to the angle because of the curvature. This angle is theta plus d theta. Now let's see. The vertical component is the one which is pulling it. The horizontal components are balancing out. So let's only talk about the vertical component. Let's talk about this. What is this? This is f sine of theta plus d theta. What is this Fs? This Fs is equal to this is Fs sine of theta. So if we subtract this, what will be the value? F of sine theta plus d theta minus of sine theta. And it will be equated as what? We know that at any point of time, theta x, sine theta x equal to theta x. So we can simply say this becomes theta plus d theta and minus theta, which is equal to Fs times d theta. And what is Fs? I just told you. Fs is equal to surface tension into the depth into d theta. So I got the F net that is acting upwards for this small piece of area. And this small forces actually accumulate and pull it upwards. So when we equate this with the mass, we already got the area, right? So this will be SD into d theta equal to the mass. How do we get the mass? Area into depth. So volume is dx into d multiplied by rho into g, rho v into g. Now you can cancel out d and d. So this becomes s d theta is equal to rho g y into dx. If you pull this dx towards this and s towards this, this becomes v theta by dx is equal to rho g s into y. Now, but this is not what they have asked. They have asked for d to y by dx square. Now, how can we get that? For that, let's look at this. So, we have been given dy by dx is equal to tan theta. Let's differentiate it again. What we'll get is equal to sec square theta, and additionally what we'll get? We'll get d theta by dx. What will happen to sec square theta? How we'll get the value? Because theta is very small, so cos theta becomes 1. And what is sec square theta? Is 1 by cos square theta. So this whole value becomes 1. So I can simply say d square y by dx square is equal to d theta by dx. This is first equation, this is second equation. What we'll get? We'll get d square y by dx square is equal to rho g by s into y. So, what do we need to remember? We don't need to remember any Young's Laplace formula. We do not need to remember what is the radius of curvature. We do not need to remember anything. Just stick to basics. That's what NEET is all about. Yeah, if it was JE Advanced, I would have said, okay, yes, if something more is happening here. But even in some of the JE Advanced that I have already shown, All problems are very simple. All basic concept. Too much of hype. Simply focus on concepts. Try to solve the problem using concept. Maths is an additional tool, definitely, but you need to able to think about them. Okay. Thank you.